We have a plan to halve the cost per kilowatt hour.
Yeah.
Last Tuesday came and went with most people oblivious that the course of human history had shifted. Now that may seem overly dramatic, but I assure you it's not. Hello everybody and welcome to an EV Resource special report and review of Tesla's Battery Day that took place on September 22nd, 2020.
Hey everyone. Well, I mean, this is definitely a new approach. We got the Tesla drive-in movie theater, basically. It's good to see everyone. It's a little hard to read the room with everyone being in cars, but it's it's the only way we could do it. So hopefully it's cool, and hopefully you can hear me. Can you guys hear me? Okay. All right, great. All right, well, thanks for coming.
If you didn't watch the event live and you're hearing or watching this for the first time, because of COVID-19 restrictions, Tesla had set up the in-person audience to each sit in their own Tesla vehicles 6 feet apart, with the presentation being like a drive-in movie. Everybody had the screens in the Teslas showing what was being presented up on the main screen, and the microphones, actually the audio was set to an FM radio channel that they could tune in and hear. So as Elon came on stage, he couldn't help but chuckle and point out how unusual the setup was. Before we recap the hour-and-a-half long event, I think it's important to give a bit of context related to electric vehicles and their batteries. The most expensive component of an electric car is its battery, and prices have been dropping from a cost of $1,100 per kilowatt hour just a decade ago to $156 per kilowatt hour average at the pack level last year. However, most analysts put the EV tipping point, when they reach price parity with internal combustion vehicles, at $100 per kilowatt hour at the pack level. At this $100 price point, the days of the internal combustion engine would certainly be numbered. Tesla has always been a leader in this aspect, and estimates recently put Tesla at somewhere just below $140 per kilowatt hour. However, all of that is about to change. Elon Musk, joined by Tesla's SVP of Powertrain and Energy Engineering, Drew Baglino, announced their plan to halve the cost of the EV battery. They outlined a 5-part plan that is truly revolutionary. And yet, the response was largely silent. In fact, Tesla's hour-and-a-half event and announcements actually sent their stock price tumbling in after-hours trading because analysts and investors were unable to grasp the significance of what had been shared. Spurred on by the climate change crisis and a genuine desire to save the human race, Elon started by reiterating the importance to, quote, accelerate the advent of sustainable energy because time really matters, end quote. He continued to say that Tesla's role, quote, to achieve this transition to sustainable energy means that they must produce more affordable EVs and energy storage, end quote. In most aspects of Tesla's product focus, batteries are of extreme importance, and for the future of the human race, affordable batteries being produced at a massive scale are essential. Tesla's battery production goal is to have 3 terawatt hours of energy storage production annually by 2030. To put that in perspective, that's about 80 times larger than Tesla's current production rate, or enough to produce 40 million 75 kilowatt hour battery packs that go into the Tesla Model 3. Now, of course, they won't be producing 40 million vehicles per year. Much of that battery production will be used in static storage and grid-level systems as well. So let's take a closer look at Tesla's plan to cut the cost of the battery cell in half. Their 5-part focus is on cell design, cell manufacturing, anode materials, cathode materials, and vehicle integration. So let's look at cell design first. Traditional lithium-ion battery cells are manufactured with tabs on either end of the battery that all electrons must flow through. Under use or discharging, lithium electrons flow from the cathode, or the negative side, to the anode, the positive side. And when charging a battery, the reverse takes place. The more electrons you have moving, the more energy potential there is stored within the battery. The bigger the battery, the more energy is stored. The same goes for Tesla's current battery cells. The 2170 form factor batteries used in the Tesla Model 3 and Model Y have 50% more energy than the 18650 cells used in the Model S and Model X. Drew Baglino explained that while the current cells have been an improvement, what Tesla needed to do when looking for the ideal cell design was to, quote, study the full spectrum of options, end quote. They determined that a low cell cost, while maximizing range, was best achieved with a cell using a 4680 form factor. And just a quick side note, if I've lost you already, and that's okay if I have, the form factor of cells describes the size of the cell. For example, a 2170 cell is 21 millimeters in diameter and 70 millimeters in length. So the new cells Tesla will be producing are 46 millimeters in diameter and 80 millimeters in length. However, building a bigger form factor battery has its downsides, and this is where eliminating the tab from the design of the cell is so crucial. As you make bigger cells, the electrons have a further distance to flow from one side of the battery to the other, and in doing so, resistance and therefore heat increase. Thermal management of batteries is significantly important to maintaining performance and safety. So they had to come up with a way to design a bigger battery cell while minimizing the distance the electrons needed to travel. Enter tabless cell architecture. By folding dozens of connections into a shingled spiral form, Tesla can eliminate the need for a tab on either end of the battery and allow electrons to flow more freely over 1/5 the distance. This reduces resistance and heat within the cell and allows for dramatically faster charging and discharging rates, as well as being the pivotal factor that allows for a larger cell. Here's what Elon and Drew both had to say about designing a tabless cell.
This is quite hard to do. So it's nobody's done it before. And it really took a tremendous amount of effort within Tesla engineering to figure out how do we make a freaking tabless cell and have it actually work and then connect that to the top cap. And it's there's a whole bunch of things that we're keeping a little secret sauce here that we're not telling everything. But
sometimes what's elegant and simple is still hard, and it took us a lot of trials, but we're happy where we ended up.
Yeah, I mean everything's simple in recollection. After you simple, everything it's hard until it's discovered, and then it's simple. So anyway, but there's a lot of really cool things going on that enable tabless, and it's really due to a really great engineering team. Drew and the rest of the team have done amazing work in achieving this tabless construction. And it sounds, I think it may sort of sound a bit silly to some people, but this is like, for people that really know cells, this is a massive breakthrough.
Tesla expects these new battery cells to contain 5 times the energy and 6 times the power output while increasing vehicle range by 16%, all while decreasing in cost and simplifying the manufacturing process. This cell form factor change allows for a 14% reduction in cost, not the entire 56% that they showed, but there are still 4 other pieces of the puzzle that they had to share with us. Inspired by the continuous movement and seamless production processes from the printing and bottling industries, Tesla sought to apply these manufacturing techniques to battery cell production. Here's what Drew Baglino had to say about it.
When thinking about the ideal cell factory, we have inspirations behind us in the paper and bottling industry, where from humble beginnings, over a century of innovation has enabled mass scale, continuous motion, unbelievably low manufacturing cost. And when we think about the lithium ion industry, which is really only in its 3rd decade of high volume production, it has so far to go to achieve similar scale and simplicity. And that was the inspiration that we set out to the team as we thought about how to marry cell design and manufacturing in the best possible factory.
When manufacturing batteries, there are 4 primary steps or components in the factory process: electrode coating, winding, assembly, and formation. In an effort to make cell manufacturing scalable and more efficient, Tesla looked to make improvements in all 4 of these areas. The first, electrode coating, may be one of the most anticipated aspects of their announcement. As I mentioned in my Battery Day Expectations episode, Tesla acquired Maxwell Technologies and started to implement their dry battery electrode process. They've since improved on that process many times, and they still expect to innovate even further as time goes on. This dry battery electrode process saves them a lot of time, money, and, maybe most importantly, factory space. As to the effect of the other steps in the manufacturing process, I'll let Drew Baglino share the remarkable change in output.
We were able to get to the point where we can implement assembly lines, one line, 20 gigawatt hours, 7 times increase in output per line. And when you're thinking about scalability and pure effort, having one line be 7x the capability is just effort multiplying.
Yeah. So
You can tell that those who were in the audience really approved of that, but Drew continued by identifying how Tesla's improvements in battery manufacturing fit into the plan at large.
And not only is all of that manufacturing innovation fantastic for enabling scale, it's also an additional 18% reduction in dollar per kilowatt hour at the battery pack level.
but wait, there's more.
And there was more, but I'm going to skip over the anode and cathode pieces of the puzzle, only mentioning that they were worth, or are worth, 5% and 12% respectively. And the last part of Tesla's 5-part focus is cell vehicle integration. And Elon really hit the point home when he compared their new design to that of an airplane fuel tank and wing design.
In the early days of aircraft, they would carry the fuel tanks as cargo. It was very difficult, and then somebody said, "Hey, what if we just make the wing tanks? What if we just make the fuel tank in wing shape?" So all modern airplanes, the fuel tank, your wing is just a fuel tank in wing shape. This is absolutely the way to do it.
So Tesla applied that design to vehicles, combined with the front and rear unibody castings that they have started to do for the Model Y. The battery pack will now become directly integrated with the floor pan and underbelly of the vehicle, not only saving weight, but also increasing torsional rigidity. It's a truly revolutionary step forward in vehicle manufacturing, and I'll leave it to Drew to describe in his own words the impact and good news of how this relates to the bigger picture.
It is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
Yeah.
Honestly, if you left it at that, it would be the most significant announcement in recent automobile history. But they continued to illustrate how this would benefit the business not only in reducing the cost per kilowatt hour, but also by increasing the range of their vehicles by 54% and decreasing the investment per gigawatt hour at 69%. So by focusing on manufacturing efficiency, Tesla is, to be honest, I'm still stunned by this a week later. And yes, it's now more than a week since Tesla's Battery Day, and I'm still digesting all of the incredible announcements. You could take this and apply it to their 402-mile Model S long range, add 54% range to that. It's just spectacular. And I think probably one of the things that they should do is, instead of having a car with a range of 500-600 miles or whatever, actually decrease the size of the battery pack, lighten weight, improve the efficiency of the vehicle, and have a 350-400 mile or so range for the Model 3. Model S will always be more. But the last two items of note worth mentioning relate to how this will affect Tesla's future products. They made two very significant announcements. The first being that they do plan on producing a subcompact model that will cost $25,000, which that is just mind-blowing. But knowing what we know now about their manufacturing process and how much they can save, I think it's very possible for them to produce a $25,000 car and still have a really healthy profit margin. And then the second of the product announcements was for the Plaid Mode Model S. It's available to order as of Battery Day last week. $140,000 roughly, but the performance is staggering, and the metrics that they announced happen to just beat out the Lucid Air by this much. A 520-mile range compared to the Air's 517. A sub 9-second quarter mile. 0 to 60 in under 2 seconds. And a top speed of 200 miles an hour. And one of the most significant factors They showed a video or clips of a video. The full video is out now. But they showed clips of a video of the Plaid Model S going around Laguna Seca in 1:30.3 seconds, which is faster than a McLaren P1. I don't know of any other car that can provide performance for that price. $135,000 after expected savings, or $140,000 if you're paying cash, pretty much. Remarkable, absolutely staggering for those who can afford it. Of course, that is not an inexpensive car. But then again, when you want a performance vehicle of that caliber, most of them are going to cost multiple hundreds of $1,000s, if not more than $1 million. So really, $140,000 is quite the steal. But all in all, that is it. My summary of Tesla's Battery Day. I did my best to bring you the most significant and important parts of the event. I did skip over a lot, but if you want to take an hour and a half for the battery event, or the full 2.5 hours of their investor meeting the hour before the Battery Day, you can watch the entire thing on Tesla's YouTube channel. They have it up. I hope you enjoyed this summary. If you have any response, comments, or anything you want to share about your reactions to the event, feel free to leave a comment below on the YouTube video, or email me at hello@ev-resource.com. But thank you very much, everybody. I'll catch you this coming weekend for the next episode of the EV Resource Podcast, which will be out Sunday at 2 p.m. Eastern Time. Thanks so much.